All right, continuing on with the recovery. So recovery is when to take the refrigerant out of the unit in any condition and put it into a recovery tank. Now we're going to have a scale in here. We need to weigh how much we take out. We want to make sure we don't overfill the tank. There's several other things we're going to talk about with this and add to it. But this is taking a refrigerant from any condition and put it into a recovery tank. Now every brand of recovery machine has different options and different names and different everything that they have going with. But almost all of them have an in and an out, right? How do you work the different types of recovery machines? How would you handle different types of recovery machines?
Wouldn't there be like a manufacturer manual with it? Don't hit me, dog.
Yes, that's exactly right.
You got one.
RTFM, read the freaking manual, right? Yes, that is the key to how to do recovery, is there's a manual that comes with this machine. And you read the manual, it tells you how to hook it up. We've included on your online site one of the manuals in there so you can actually see how that happens, how to work that. But there's a manual for you to be able to do that. There's a manual in there, and it tells you how to hook it up. It tells you what to do. It tells you what valves to turn. It has pictures in there usually even, so you can hook it up that way. It tells you what to do. Read the manual. And then the next question, well, what happens when I'm working on this unit and the manual's not there? What do you do if the manual's not there?
You pull the part number, model number.
You can Google it. Now everybody's got phones. You guys have stuff that we didn't have back in my day. You can Google it. You can get online or use some other search engine other than Google, but you can ask Siri, whatever. You can put that model number and the brand of that unit in there. The brand and model number is going to have, you can pull up a PDF of the instructions. How great is that? But you should familiarize yourself with the instructions before you use it. Also with this machine is this cord. The cord that's coming out the back that we plug it into is very important. You need to read the instructions because they'll usually have a warning on there of how many feet you can have that from the plug. The longer my wire is, the more risk is for a voltage drop from one end to the other. So if you use an extension cord wire, that wire is going to be rated with a gauge. AWG, American Wire Gauge. So here we have a pretty nice thick extension cord. Just because it feels thick on the outside doesn't mean that that's what it is. We really need to look on here and see if it has a gauge on here. So if we look on this, I'll have to get my glasses out or a magnifying glass to really probably see this one. It's rated for 300 volts. It's pretty worn.
Hopefully it's had better days.
Well, it's got it in millimeters.
The Canadian system.
Metric is significantly better than imperial.
Yeah. You want to convert anything? Add a 0 or take away a 0.
That's right. I love it.
Move the decimal point. Yeah, that's great.
Convert feet to a mile.
What's the freezing point of water? 0 degrees.
Here it is. It's AWG, but I
Can't read it.
just can't read it. So, but you want to make sure it's a thick enough extension cord. So we'd have to really look on here and see. If I keep looking, I'll eventually find it. But one of the things about this is a good thick extension cord. It looks like a good quality cord. I need to look at the numbers just to make sure. But notice how there's 3 outlets here. A lot of times this can be a problem because everybody wants to hook 3 more things to it. Well, you got to make sure that the amperage is going to handle it. So the voltage and the amperage. So the length of this wire and the amperage of what the load is you're working with is going to determine what size wire you should use. Notoriously, people want to use a very thin extension cord because they're lighter. We use a thin extension cord. It's also a smaller gauge. Smaller gauge wire means it can handle less amperage, less current. So if it can handle less current, you're going to end up with more of a voltage drop. You end up with a voltage drop to your machine.
You end up with higher current.
You end up with even higher current, which means you melt the wires. You melt the insulation off the wires. So very important is when you're hooking your machine up, and sometimes your boss is going to provide you with a recovery machine, and so at some points they don't. And at some points you want to get your own because it'll be a lot faster. You want to make sure that you have the wire going to that the correct size so you don't have a voltage drop and a current rise and end up trying to burn out that motor. right? So you want to make sure you use a thick short as possible. Thick cord, right? Lower gauge wire, short as possible.
And even if the outer cord is thick, that doesn't mean inherently that the inner cable will...
That's right. Just because the outside's thick doesn't mean that the wire's thick.
You'll add extra insulation to
make it look
feel thicker and look thicker.
That's why I want to make sure I read on this cable to see what it says. And this one I need to clean it to really see the numbers on here. But I need to really read it and see it. Now another thing is, when you, a lot of people want to have their extension cords, and they have these nice, really cool extension cord rolls now, right? Little handle on it. It's got a little, you can just wind it up. It's pretty nice, huh? There's actually a catch to that. What happens when we take electricity and we put it into a circle?
That makes an electromagnet.
Makes electromagnets. It makes an inductive load. So we want to make sure that anytime that we're using extension cords, that it's unrolled. So if you have a 100-foot roll extension cord, you're having to unroll that whole 100-foot cord. So what I want to do with that extra is not roll it up. I'm going to put it out here like so, and I can zigzag it back and forth. I'm going to be okay, but if I put it into a circle, that creates an inductive load. We'll have a voltage drop from that. You won't have an electromagnet because the positive and negatives are going to equal each other out, but you will end up with a voltage drop. Somebody a question? I saw a hand go up.
You answered my question.
Oh, okay. So that's what we want to make sure we do is when we're having that extension cord, we want it as short as possible, thick gauge. And on some of the brands, they'll even tell you what gauge cord to use for what length. And some of them will say definitely not over so many foot. Really and truly, I don't want to use anything over 50 foot on one of these machines. And that's going to have to be a really thick gauge wire for 50 foot anyways. I want to make sure I don't have any problems running that recovery machine. That recovery machine pulls a decent amount of amps. It has a compressor in there, a little compressor in there. It's having to pump all that refrigerant. And as the pressure goes up in that tank, the more work that motor's having to do. Right? Does that make sense? Mm-hmm. Especially on a hot day. On a hot day, it's going to have the temperature up even higher. It's going to have to do even more work. Does that sound good?
Yeah.
Make sense? All right. So, cords. Want to make sure that extension cord is in good shape. So, recovery part 2, we'll have cords. Also, with recovery, want to make sure that this tank that we're putting it into doesn't get too hot. As I'm increasing the pressure in this tank, what's happening to the temperature? It's going up. So what's happening to the pressure inside the unit? It's going down. So as I'm running this recovery, my pressure in the unit's doing what? Dropping. What's happening to the pressure in my tank? And then the unit? Tank? Unit? Tank? We end up with a higher compression ratio. It's pulling from a much lower pressure and pushing to a much higher pressure. That compression ratio is hard on that compressor, right? It's a lot of work on it. So at some point in time, the pressure in here could get so high that we trip one of the safeties in here and it shuts off to wait for it to cool down. They can't push anymore. So maybe we're going to worry about busting a hose or who knows what else. We want to make sure that this doesn't get too high. So how can I keep the temperature of this down?
Put like a cooling blanket on it, or put like a coastal fan?
Cooling blanket. We need to invent one of those because that would be great when I sleep in the summertime. It's a good idea. Work at that invention. Just run some refrigerant. That's a good idea. If we ran some glycol in a thin hoses through a blanket, we could actually have it absorbing heat, little refrigeration unit at the end. Let's work on that.
The only problem with that, though, is
I like it.
Sleeping and then turning over, they bust.
Oh, that's true. There would be that problem.
Trial and error. Yeah, EPA
We'll work on it. They have
Designed for
air-conditioned seats now. We can get air-conditioned beds. Just need to work on that.
R22 and you design it.
Yeah.
All right, a fan. We could use the fan on it. It's one way. How else?
Can you put it in a cooler to cool water? Just water?
You could put it into a big tub of water. We could do that. We could put it in a big tub of water.
That would be extremely inconvenient on somebody.
No, we actually do put it in buckets of water sometimes. Let's go do this real quick.